Cool. 1095, find in mountain away. This problem is an interactive problem. Oh, that's interesting. You may record that an array A is a mountain array if and only if, excuse me, length of A is greater than or equals to 3. There exists some I with I between 0 and A or n minus 1 such that uh, it is, I guess, to, oh, it is strictly, well, technically increasing to A sub I and then strictly decreasing from I to n. Okay, given a mountain array, uh, mountain or return the minimum index such that mountain or that you get index as you go to target. Man, I gotta read this again. I've been just saying stuff. If such an index doesn't exist, return -1. You cannot access the mountain array directly. You may only access the array using a mountain array interface. Uh, you may recall, why is this like a standard term? I feel like they're like, oh, it's like, by the way, if you didn't know, this is a mountain array. I'm like, this is the first time I've heard this term. I mean, I could guess it if I need to, but I don't think I. But okay, so we are given a mountain array. Return the minimum index such that mountain array that get index is equal to target. What does that mean? Oh, just the small. Okay, just the smallest index in which and we're given target, I guess. Okay, I guess I'll look at the example. I have to figure it out. You can access it. You only have 2 interface, get and length. Submissions making 100 calls will be called judge. Okay. Also, any solution attempt. Okay, well, yeah, just don't cheat. Okay. So let's say target is 3. 3 exists in the array at index 2 and 5. Return the minimum index, which is 2. Okay. Target is equal to 3. 3 does not exist in the array, so we return -1. Okay. So this is actually, oh, I think nowadays we talk about it a lot, and that's one of my favorite things is the binary search. And clearly, to some degree, n is 10,000. Okay. So in some degree, yeah, like there's some divide and conquer here, but it is actually not binary search that you want. It's something called a tertiary search. Um, and and in binary search, if you recall, you want a function that is, and sometimes you could convert a function to a function. You want something that's monotonically increasing or decreasing, or yeah, I mean, just that, monotonically increasing or decreasing, which you could go from 0 to 1 if you wanted to think about it in binary. Um, but uh, but yeah, for how do you describe ternary search? So you could use ternary search basically on stuff that is I forget, but I forget the mathematical terms for these things anymore. But I need to. I haven't done that in a while. Actually, ternary search, but essentially it works for this, like in a mountainy type, because it you could use it to find the basically instead of how I would think about it is if given a binary search, you take a middle and then you take one of the halves, right? For ternary search, you divide the space into three well thirds, and then you try to figure out which third to chop off. And this works for functions that are I mean, it works with this type of function, but I forget. There's a specific mathematical term for it, and maybe someone could help me out. But in ternary search, but this would work with ternary search, and that's what I'm going to do. And because you're chopping off 1/3 each time, I forget how the math goes, but I mean it's still log-ish, but it's not as fast as log 2, for example, right? Uh, but essentially, you eventually get to eventually get to. But let me go. I think that's mostly how we put it. And I don't know if there's a way to do it without ternary search. Well, maybe there is, but I'm not going to think about it that much. But I'm going to put the name of the algorithm here so you could Google it if you like. But, okay. And it's equal to, no, wait. I just type round away that length. Okay. So basically just 2/3, 2/3. So 2/3 you get 66%, and then you do it say 20 times. Okay, 20 is not enough because that narrows it down to, okay. Like say if you do 30 times, then yeah, okay. That should be so we have way enough cores to do it, but yeah, I mean I think language is not. I mean I think it does as long as you choose any reasonable language that you could YouTube or Google on. I don't think it matters that much. I think as long as you guys choose one and stick to it. You want to be really good at one language and not okay at all languages, if that makes sense. Because that's what people will be looking for. People will ask you specifics about you know yeah, about one problem. Sorry, I'm half typing. Okay. How do I do this again? Is that right? Yeah, I'm missing something. But like this. Yeah, you can't go wrong. Java is a known language for older than a lot of people alive now. It's like 30 years or something like that. I actually don't know, but it feels like forever. So so there are a lot of good tooling around it. But okay, I mean we have 100 cores. We should be okay. Okay. I'll mount in a way that good. We should just caching these just to. Let's see if uh, hmm, how do I want to do this? I guess I don't actually need this yet. If target is there's some like weird case where it could be on the other side, I guess, actually. Mm. Okay, so basically if target is if this point is bigger than target, let's do it the other way first. If target is bigger than that, then we could eliminate the first half. Okay, here's your limit 1. Otherwise, tail is equal to mid 2. Continue. Sorry if I'm a little slow. Haven't done ternary search in a while. I think that's I think that's how I would find the max or the min, but maybe the target is not the right way to do it. Maybe the target is throwing me off. I mean, we could use this to get the max. And then we could binary search on both sides. Is that too many calls? Okay, let's play around with that then. I don't know if this is actually fast enough. I mean, the 100 courses, like the big O notation is, I think, fast enough, but I don't know if I'm going to get it under 100 cores. Should be okay, though. If this is bigger than that, then it's not on the second half. Or second, third, or third, I guess. I forget what happens if they're the same. They're the same. I guess you just take the middle dirt. Cool. Okay. Lower this constant for now. Maybe name it could be better. Let's just return it for fun and then run it just to see how it goes. Okay, how it goes is that syntax error. Oh. I had this in there. Is that deleted by accident? Maybe. Ah, I have to use this in this as a thing. Okay. Oops. Maybe what I'm doing is not necessary. Now that I'm writing more and more. 22. What am I not getting? Does it not print before the... Okay. Did it get the correct max? Yeah, I guess so. Well, maybe. Oh, wait, no. And then break. Yes, okay. Yeah. Equals I erased. I guess 7 or 8. That's no, that's okay. But I need to do one for when it's 10,000. Okay. And now that we have the max index, we could binary search on the left and the right, I suppose. Maybe I should put this somewhere. Yeah, I don't know if I'm doing it. I mean, I know that I'm doing it right-ish, but I wonder if there's a easy, maybe there's a way that doesn't require finding the max, which I'm just being unnecessary about, but we'll see. Uh, and then now it's just binary search, right? Yeah, okay. Usually I do some like array reverse thing, but but I guess I just have to write two of them. Uh, mm, is that not I don't know. Maybe there's a better way. Maybe you could do repeat doubling type thing, but I don't know. Not sure if I believe that. Okay, let me find um, increasing. I have a feeling I might have to. Well, maybe I could generalize this a little bit, but mm, is that free? I guess this is free actually. It doesn't count as one of the course, so but I'll just still. I think actually I should have tested it, but that's all. Well, okay. It is greater than target. That means it's on the lower half. Okay. Nope. Something like that. Not to find the other one. I think in theory I could have. I could maybe co-opt this in the same one, but can I? Yeah. I mean, I just have to change this function, but YOLO. Let's see. I'll set a good example, maybe. I think if I did this on a contest, I probably would have just copy and paste and be done with. like it's like some XOR stuff. I think you could do it with XOR, but I think I'm just gonna be lazy. Because also this is set up incorrectly as a result. Maybe I should just copy and paste it. But it's not too late. I'm just gonna copy and paste it because I think there's just too many places for things to go wrong. I would love to hear what the better solution is afterwards, I suppose. Well, assuming that this actually passed first. How does this work? It was right before, maybe. Oh, this is the case. Oops. Okay. How many cores do I do? Not to generate a ridiculous thingy. Only 5 cores fit. Okay. 10,000. I'm going to do this off screen for a second. I'm going to generate a test. Using arc or whatever. Seek. 10,000. What's it called? And then I'm going to do it in Excel. Hang on. I'm just generating a test. Sorry if I'm doing it off screen because I don't know. I'm just going to do it in Excel. Oh wait, is it? Okay, so actually, well, it should be okay actually. Oops. What's the format? Commas. Yep. Sorry, friends. Okay, now I gotta. Let's just say. Let's find one that isn't there. Yeah, only 51 cores. And then let's do it again, but maybe mistakes were made. Okay, I'll just change this one. Say, I don't know, 800. Okay. Yeah. Okay. Only took 50 course. I'm still have a lot of course left. Fingers crossed. Okay. Cool. Yay. Uh, it's just the first time today where I got something right in the first try, which is kind of sad. But hey, I solved it. Yeah, and I have good times, I suppose. Though I don't know. I don't know. But oh, and there's a peak index problem. Maybe that's the one that asks you to find a peak, which I guess I already did. And I don't know. Yeah, let me take a look at how Ambrax did it. But, uh, hmm. Oh, I see. Oh, that's cool. Yeah, you are right. Uh, yeah, yeah. Thanks, Ambrax. I think, yeah, essentially you did a binary search instead. I think maybe that is a case where so what? Let me summarize what Ambrax does. He did actually kind of funny because I alluded to this a little bit in the beginning of this problem, which is that for binary search you can actually as long as it's monotonically either increasing or decreasing, then that's good enough, right? Which I also said actually, I think, which means if you kind of plot it in a binary, like 0, 1, you could still true. And what Mbrax did is actually he did a binary search on basically what do we call it? Like on adjacent indexes, true if it's increasing and then false if it's decreasing, or the other way around. I didn't look at your code per se, but basically, and then using that information, you could find a peak by binary search. Um, I mean, I think that's clever. I think, and this works because the indexes are integrals or integers, and because they're integers, um, there's no way for the peak to be between two indices. I mean, I think that's obvious. I mean, you can have a peak not be in a way index, but but for me, yeah, I mean, I did a ternary search, but this actually also work if this function is kind of like if you're not giving it away, you're giving a function, and it's a and the function the f of x could or actually both x or f of x could be is in a set of reals instead of natural numbers or whatever. Is it naturals? Yeah. Yeah. Um, so if that's the case where it could be doubles and floats, then you have to do what I did. But because this is indices, you could take advantage of that properly to binary search on it. So that's pretty clever, and you don't even have to know how to do ternary. And then the other stuff, I think Recenter did it the same way. I didn't look at it again, but I imagine so. You did much quicker, but maybe I talked a little bit. That's my excuse. I'm sticking to it. Yeah, and you did the thing where you used one function. I think I worried a little bit about, I don't know, just the debugging aspect of combining these two functions. I mean, I think given enough time, I would do it, but I think I was lazy and give it out. Uh, um, excuse me. Um, but yeah, I mean, I think I was initially going to say that, yeah, it's a little tough for an interview problem if you need to do ternary search. I don't think that's something that general people familiar with, but with your optimization, um, like yeah, like I think I think I've talked about this a lot, which is that I love binary search as a problem because I feel like at essence is divide and conquer. Uh, yeah, just divide and conquer without the marriage, if you will, of like merge sort or something like that. And and you could do it in a number of ways. But that's it's a good skill to break a big problem into smaller chunks, right? And also it's like relatively fundamental. Like you're not using anything fancy or anything. Like you're not you don't have to learn a like crazy graph theory. to know certain things. You just like binary search. Everyone is taught binary search pretty early on, and people conceptually gets it early on. So I think that with MBlacks's optimization, I really like that. And I don't know, yeah, because then it's just two binary searches. So that's pretty cool and pretty clean. Uh, what, how long did I take? I took wow, it took 35 minutes. Really? Did I just chat a lot or? uh, I, okay. I mean, I felt like I didn't spend that much time, but maybe I was chatting a lot. So I'll look at it later when I go through the tapes. Because I knew how to do it immediately. I just didn't know if there was a cleaner way, and I knew that relatively. I knew that this would be good for sure. And I even did the self-that course for that reason. Oh, I guess I did take a couple of minutes. Um, uh, I did take a couple of minutes creating this test case, so that's why the big 1 to 10,000 test case, because I didn't want to get burned by time limit exceeded. In this case, it's not going to be time limit exceeded. It's the 100 core limit. Um, but yeah, I mean, it's not so bad. It is. I mean, it's nice to get good practice, but I knew how to do it per se in theory. Um, yeah, the cache. I think. Oh yeah. I did actually forget to talk about the cache. The cache I actually did appreciate the cache because in some way, I mean, yeah, you could draw parallels with memorization, which is okay. But actually, it is something that is probably the closest to real world. You will in like you have an API call that calls like I don't know Google or some external service, and this is essentially what this is in a weird way mocking, especially since your API calls you only get 100. Once you cache it, and in this case it shouldn't change anyway. If it changes, then someone, excuse me, messed up somewhere. But yeah, so this is something that's like way similar to quote unquote real life, if you will. So that was something I thought about it. And in theory, you would maybe write tests around this, but not in this case, I guess. But maybe if it's slightly more complicated, then you could kind of even in your test mock it out or something like that. And if you're an interviewer, maybe you even talk about that because these are software engineering practices with testing, which I'm a big fan of. But we don't talk about it enough on the stream because it's Leetcode, I guess. But and some of that is subjective, and sometimes I don't know. I had a very good mentor around testing, and he was very very strict, but really taught me like how to do it because he would not accept anything less. But once I kind of uh, start thinking about things in terms of test, like everything becomes easier. Uh, no. I mean, like it's a now a friend of mine, but yeah, I think I just didn't appreciate test until I don't know. I had to do a refactor for one, for example. And I remember during one of my previous jobs, I did was tasked with a refactor without testing, or without proper test set up, and I at the time I didn't know how to do it because I just and Google wasn't that good back then, or like maybe Google was good. It's just that there's not much to Google on because people didn't write that much back then. There's no YouTube. Uh, but if you have to do a refactor testing account, okay. Let me. I've been rambling a little bit on tests, but let's talk about this problem a little bit. So there's two ways to go about it, and now, thanks, Emma's for thinking about the other one. I'll go over mine first because I wrote it. But basically, I mean, I guess I talked about this a little bit in the beginning. And I guess that's why I actually spent some time talking about ternary search instead of. So I think that's why it took so long. Okay, maybe I accept that. But yeah, with ternary search, you maybe I will explain this what I'm doing again because I already did a little bit, and also Google it if you're not familiar with it. I don't think it, and I say that because I don't think that should be within scope for an interview. I think that's a little bit on the obscure side. I mean, and it applies to certain problems, obviously, but in this case, you don't even need it. It's just that I have happened to know it and it works for it. Um, but yeah, it's just two binary search. I think so. The peak. So you can think of it. I'll explain MBlack's solution, which is binary search to find the peak. So you could think about it as a binary function of are these two adjacent numbers increasing, right? And then it goes increasing. It goes or decreasing depending on how, it doesn't really matter, right? They're just inverse of each other. So it goes false, 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 or 0, 0, 0, 0, 0, and then 1 after it hits the peak, and then it's all the way 1, right? So if you do it that way, then then you're trying to find that point where it goes from 0 to 1, in which, at that point it's a simple binary search recurrence where you you test a number. If it's 0, it's in the second half. If it's 1, it's in the first half, and you just keep on doing it that way. Yeah, you find the low bound, and maybe like -1 or something, but like you have to take care of the edge, whatever. But that's but that's essentially the idea. And once you find the peak, then you have it sorted away or reverse sorted away, and you just binary search on that. That part is very fundamental. This is actually kind of a little bit easier on the hard. Maybe not. Maybe, well, I mean, I say that and I didn't do it your way. Maybe so. I don't know. I mean, this goes in a number of ways. I don't know, whatever. But I think, overall a good problem. I think I actually enjoy it. Like I mentioned, I like it, and maybe I'll steal it if I when I get back to interviewing again. To be honest, my only problem is obviously if they've seen it, but I do like the API part, just because it forces it forces you to not do some crazy optimization stuff, maybe. Well, I mean, because the other obvious answer is just linear, which linear scan to get the max and then binary search, which is fine. But you don't even need to get the max in that case. You just do a linear scan, right? But so I think I've seen something similar to this before. I don't know if it's on Leetcode, but yeah. Yeah. But I mean, like, if I think I didn't say this right, but if this code or if this problem isn't quote unquote interactive, where you have like 100 API calls, then everyone would just do it linear, right? I guess that's what I meant. Maybe I didn't say that right, because then they cannot test your calls. But because of the way they structure it, you're forced to only get 100 calls, which is more than enough, because 2 to 100 is, well, I mean, more than like the size of the universe or something. Atoms in it, or am I mixing my dimension? But it's close. It's something really big, right? Like maybe more than a number of atoms in on Earth or something. But something big. But like, yeah. So 2 to 100 is big enough. I guess that's my point. So you could even be lazy about it, or 2 to 50 even is more than enough to find a number to an array of 10,000. Like, was it 2 to the 15 or something like that? Is probably big. 14. It's already bigger, right? So so yeah. I think that's all for this problem. Yeah, 2 to 14. So in theory, you only need 14, maybe 28 if you double it to kind of bisect everything, right? So you can, and maybe a little bit more because you need more cores, but that's what the allowance is for, and that's. But as long as you don't do it linearly, you don't need that many cores. It seems like. I think I was a little cautious, but yeah. Okay. Cool. Thanks for the suggestion, Mbox. Like I said, I dig this problem. I think I still think maybe it's a little hard for an interview problem, but I mean, or in the start, like I would definitely give it. So I don't think it's a little hard for an interview problem, but I think it's hard to set up as an interview problem because of the API usage. So I don't know if like I don't know if you would see this particularly. Like I don't know if you would see this problem on site, but I could see it being just like maybe if you do one of those like HackerRank type interactive interviews. But I think in general, you should be familiar with binary search. I think like this is the level of difficulty that I would definitely get people to do. So yeah. Okay. Could I have done better? No, I mean I think I knew the answer immediately. I mean I think I could have cleaned, like I said, I could clean this up. That's fine. I mean I just want to get it right and first. Maybe I could. I mean the yeah. I mean the binary search is faster than this for sure, but not by that much. So I think it's fine. Like isotonically, it's the same ish, different based on the log. But no, you're not supposed to tell me that is a binary search. But I'll do another hard first, and then maybe we'll play around with it. But but yeah, I mean, I think I did mostly okay. Like I said, I like caching it in general, just in case I reuse numbers. But yeah, cool. uh, yeah, cool. I think that's what I have for that for.